Hello, we are the frontliner of tech world, especially specialized in AI and related technology advances. Today's topic is Tenstorrent versus Nvidia AI hardware showdown.
This is an excellent comparison that highlights the emerging battle in AI hardware between established players and ambitious challenges. Let's break down the Tenstorrent AI Blackhole concept and architecture versus Nvidia's Blackwell and CUDA ecosystem.
Core philosophies and market positions.
Nvidia, Blackwell plus CUDA, the undisputed incumbent. Its strategy is a vertically integrated full-stack ecosystem: hardware, software, libraries, cloud services. CUDA is a moat that locks developers into Nvidia hardware.
Tenstorrent, the ambitious challenger, founded by chip legend Jim Keller. Its strategy is horizontal and open. It aims to decouple hardware from software, promoting an open-source software stack based on RISC-V to avoid vendor lock-in. AI Blackhole is part of this disruptive vision.
Tenstorrent's AI Blackhole concept and architecture.
The term AI Blackhole is a marketing metaphor for Tenstorrent's solution to a critical problem. As models grow exponentially, the traditional CPU-GPU scaling paradigm hits a wall due to memory, interconnect, and control overhead.
Number 1. What is the AI black hole?
It's the point where the computational demands of a large AI model, e.g. a 1+ trillion parameter model, are so immense that they collapse traditional compute architectures. The system becomes dominated by data movement, orchestration overhead, and memory bottlenecks rather than actual computation.
Number 2. Tenstorrent's architectural answer: data flow and 10-6 cores.
10-6 cores, the heart of their Grayskull, Wormhole, and Blackhole chips. Each 10-6 core is a heterogeneous, programmable compute tile containing a RISC-V CPU core for control, a SIMD vector unit, a tensor engine for matrix math, and 5 network-on-chip routers for direct core-to-core communication. Spatial data flow architecture. This is the key differentiator. Instead of having a few massive compute units that fetch data from a vast centralized memory pool, like a GPU, Tenstorrent uses many small, efficient cores. Data flows through a mesh of cores in a coordinated wave. Computations happen as data arrives at each core, minimizing trips to external DRAM, HBM. The on-chip network is as critical as the compute itself. The Blackhole chip, e.g. TT Blackhole, their flagship data center chip designed to avoid the AI Blackhole problem. 120 10-6 cores in a 10x12 mesh. Maximal on-chip communication, emphasizing keeping data moving between cores. Scalability via PCIe and Ethernet. Chips can be connected directly via Ethernet, aiming for more flexible scaling than Nvidia's NVLink. Software stack, the open challenge.
Open source and RISC-V foundation. Tenstorrent's entire software stack is open source. Their cores use the RISC-V ISA. Temporal matrix, TM, their parallel programming model. Developers describe data flow graphs, and the compiler maps them spatially across the mesh of cores. Goal: break the CUDA lock-in. Allow code to be compiled for any compatible hardware, theirs or others adopting the stack.
Nvidia, Blackwell architecture and CUDA ecosystem. Nvidia approach is evolutionary refinement of the dominant GPU paradigm, massive parallelism plus extreme bandwidth.
Nvidia's approach is evolutionary refinement of the dominant GPU paradigm, massive parallelism plus extreme bandwidth.
The CUDA ecosystem, the real moat. This is Nvidia's overwhelming advantage. CUDA platform, a mature, deeply optimized programming model that developers have used for 15+ years. Libraries, CUDNN, CUBLAS, TensorRT, and now CUDA-X libraries provide peak performance building blocks. Frameworks, seamless integration with PyTorch, TensorFlow, and JAX. A model to CUDA is all it takes. Entire stack, from drivers to cloud services, DGX Cloud, and NIM, it's a turnkey solution.
Head-to-head. Feature: Tenstorrent AI Black Hole approach.
core philosophy is open, horizontal, and data flow. Avoid vendor lock-in.
Versus Nvidia's closed, vertical, full-stack integration. The more you buy, the more you save.
In compute paradigm, Tenstorrent's spatial data flow. Many small, smart cores. Computing follows data.
Versus Nvidia's massive parallel SMIT, fewer but much larger streaming multiprocessors, SMPs, data is fetched to compute.
In key strength aspect, Tenstorrent's potential extreme efficiency for specific data flow graphs. On-chip network reduces memory bottleneck.
Versus Nvidia's raw peak performance, unmatched memory bandwidth, and seamless multi-GPU scaling.
In memory system aspect, Tenstorrent relies on efficient data flow to minimize HBM trips. HBM capacity and bandwidth is secondary.
Versus Nvidia's HBM is king. Nvidia pushes HBM3E to its limits, 8 terabytes per GPU. NVLink creates a virtual giant GPU.
In interconnect aspect, Tenstorrent emphasizes Ethernet scalability for massive clusters, versus Nvidia's NVLink is proprietary and dominant, unmatched speed for server-scale systems. In software stack aspect, Tenstorrent's open-source TTMLIR CUDA based on RISC-V, steep learning curve, less mature.
Versus Nvidia's CUDA, the industry standard, immensely mature, optimized, and supported.
In programming model aspect, Tenstorrent's temporal matrix, TM, describe data flow graphs, versus Nvidia's CUDA C++ Python describe parallel kernels, more familiar to millions of developers.
In ecosystem aspect, Tenstorrent's small but growing targets hyperscalers who want control and hate lock-in, versus Nvidia's vast, encompassing every AI researcher, startup, and cloud provider.
In target aspect, Tenstorrent's disruption, the Linux of AI accelerators, wins by changing the rules, versus Nvidia's domination, the Windows of AI accelerators, wins by being indispensable.
Strategic implications. Nvidia's play, we have the only complete, proven high-performance solution for giant-scale AI. The cost of switching or experimenting is too high. Their integration from silicon to cloud is their defense.
Tenstorrent's play is the AI black hole is coming for traditional architectures. Our efficient, open, data flow approach is the future. Avoid lock-in and own your stack. They are betting on architectural inevitability and open-source ideology.
It's a battle of ecosystem versus architecture, and inertia versus idealism.
Nvidia Blackwell is the safe, powerful choice for anyone who needs state-of-the-art performance today and doesn't want to rebuild their software stack.
Tenstorrent is the visionary, high-risk, high-reward choice for entities like large cloud providers or governments planning for a post-CUDA world, willing to invest in a new software paradigm for potential long-term efficiency and control gains.
Tenstorrent isn't trying to beat Nvidia at its own game, it's trying to change the game entirely. Whether the industry will adopt a new game while the old one is still delivering record-breaking results is the central question. The second part of this video, let's tell you a brief story of the legend Jim Keller, the Silicon Whisperer.
Jim Keller is a legendary figure in semiconductor design, often called the rock star of chip architects. His resume reads like a history of modern computing. He was a key designer of AMD's K7, K8 microarchitectures, which powered the Athlon 64 and beat Intel's Pentium 4. The lead architect of Apple's A4, A5 chips, the foundation of the iPhone and iPad. The brain behind AMD's Zen microarchitecture, which revived AMD's competitiveness, and a contributor to Tesla's self-driving AI chip. Keller is known for solving seemingly impossible engineering problems with elegant, simple designs.
Tenstorrent, the ambitious AI bet.
In 2016, Keller joined Tenstorrent, a Toronto-based startup founded by Ubisha Bazic, who had worked on AMD's graphics architectures. The company's mission was bold, to design high-efficiency AI and compute hardware for the coming wave of machine learning, especially inference, running trained models.
The vision.
AI-centric design. Tenstorrent's chips, like the Grayskull and Wormhole processors, are built from the ground up for scalable AI workloads using many small, efficient tensor cores on a single chip. RISC-V embrace. Unlike most AI chip companies using ARM, Tenstorrent adopted RISC-V, an open-source instruction set. This gives them full control over the architecture and avoids licensing fees. Software-defined hardware. Keller emphasized that software is key. Tenstorrent built its own software stack, TensorFlow, compiler, and runtime to let developers easily program the hardware. Scalability and composable AI. Their architecture allows chips to be linked together efficiently, aiming for both data center and edge AI applications.
Keller's role and philosophy.
Keller joined as president and eventually became CEO 2021 to 2023. He brought not only engineering brilliance but also a system-level mindset. He pushed for heterogeneous computing, mixing AI, CPU, and other accelerators seamlessly. He advocated for open standards like RISC-V to foster innovation and avoid industry lock-in. His mantra, make the hardware do more with less, efficiency over brute force.
Challenges and the road ahead.
Tenstorrent entered a fiercely competitive AI hardware arena against giants like Nvidia, AMD, and Intel, as well as other startups. In 2023, Keller transitioned to CEO and later moved to an advisory role, with Bozic returning as CEO. The company shifted towards licensing its IP, designs, and software, in addition to selling chips, a strategy to scale faster.
Recent moves.
Tenstorrent has partnered with companies like LG for automotive AI and Samsung for chip fabrication. It continues to advance its RISC-V-based AI chip roadmap, aiming to challenge Nvidia's dominance by offering more programmable, efficient alternatives.
Why it matters.
Jim Keller's involvement with Tenstorrent symbolizes a broader shift in computing, the rise of specialized, open, and efficient AI hardware. While still a challenger, Tenstorrent represents a bet that the future of AI compute will be diverse, customizable, and built on open standards, a vision Keller has championed throughout his career. In short, a chip legend plus an ambitious AI hardware startup plus the open RISC-V ecosystem equals a high-stakes bid to reshape how AI gets done. The story is still being written. Thank you for watching the Frontliner of Tech World program. See you on the next exciting topic. Subscribe and give us a like on our video if you like the topic. Goodbye.